So remember, this is the approximate change. This is the actual change. Okay, and this is the total differential. Okay, this is for 3D, the same case. Yeah. Okay, we start here, right? Correct? Okay, suddenly my pen is not working. Let me check again. Check it. Okay. Okay, today we will learn about local extrema of multivariables. So we have local relative extrema is values in open interval. Extrema refers either maximum or minimum. If we see here, so this is maximum, right? Maximum curve. So this is the point for the maximum curve. And then we have minimum curve, minimum surface. So this is the point where the point is minimum to the curve. And the saddle point. Saddle point means there is no max, there is no min. Okay? No max, no min. So we call them saddle point. Surface that curves up in one direction and curves down in a different direction, resembling a saddle or a mountain pass. Okay? So this is just the geometrical interpretations. So how do you find local extrema points? Okay. For sure, this will be come up for your final or test, maybe. So you have to know this. Suppose FAB is a local max or local min. If Fx or del F del X and del F del Y exist at AB at certain point, so Fx AB 0 and Fy AB 0. Note that the reverse statement of the theorem is not necessarily true. Okay, you no need to know this. Apply AB such that Fx equals to 0, Fy equals 0 is called a critical point or stationary point. So to find the local extrema point, the first step is you have to find the critical point. You might get a lot of critical point, but not all critical point will be max or min. Maybe max, maybe min, maybe saddle. So but for the first step, you have to find the critical point. Step 1. As I told before, you have to find the Fx and Fy. Let both Fx and Fy equals to 0. Okay. Just equate to 0. Solve this first, and then you will find the xy. The xy will be the point. So you might get more than one point. Okay. Second derivative test. Suppose that fxy is a function of two variables that has continuous second partial derivatives on a region R, and AB is a critical point in R. Let GAB equals to fxx, fyy minus fxy squared. So this is the formula to find the G. Okay, or we call them determinant form. So actually, this is simplified from this. So this is determinant form. So you can see that sometimes we call them discriminant. Okay, so we times this fxx fyy minus fyx times fxy. As I told you before, Euler form, fxy and fyx are the same. Okay.
The final message, yeah. B3
Hello?
minus B2 negative rho B.
So thank you for your mute. Okay. Then FAB is a local maximum if GAB more than 0 and FXX less than 0. So later we will do examples so that you can understand. FAB is a local minimum if GAB more than 0 and FSX more than 0. So actually they are both same, right? But it is depend on fxx. Less than 0 means maximum, more than 0 means minimum. And then AB, FAB is a saddle point if the GAB less than 0.
Okay.
Can you mute? Conclusion, if GAB equals 0, which means the test is failed. Okay? Okay, so we come to example. Okay? We do some example. 2y squared y cubed minus 6xy minus x squared. So the question is find the critical points of the following function and determine the nature of those points, either local mean, local max, or saddle. We say them local because they might be more than one local. Okay, we try here. So first, what we have to do? At the first step, as I told here, step 1, you have to find fx equals to fy. Step 2, equate them to 0 and solve the simultaneous equation. So if you see here, fx from here. So as I told you before, to find this respect to x, y is constant. So this is 6y squared. Okay. For fy, for if fx, this will be 0. And this will be negative 6y minus 2x. Fy, 6y squared minus 6x. And this will be 0. And then equate this both 0. Okay. Equate this with 0. Equate this also with 0. So you can solve for x and y. I'm sure that you have to master on this. Okay. So here you will get 2y, which means you will get 2x also. So your point you have 0, 0, 9, negative 3. So from these simultaneous equations, you can get a critical point, but you have to know the nature of the points, either saddle, local max, local min. That's why after the step 2, you must get the step 3, which means second derivative test. You have to find the discriminant. Okay? If g more than 0 and fxx less than 0, local max. If g more than 0, fxx more than 0, local min. If g less than 0, straight away, you don't need to find fxx, will be saddle. Directly, you don't need to find fxx. No conclusion if equals 0. So don't worry, we will make sure the question will have ID3. Okay? But if you find something like this, straight away you can see no conclusion. Which means the test is failed. The test fails. Okay? There's some breaking point there. So we have these 2 points. Okay. And then, okay, don't forget to find fxx. So you already have the negative, right? Here. Your fxx is negative. So might be local max. But you have seen another point. fyy to fy. fxy negative 6. So you use the formula this times this minus this square. Right? As I told here. The formula is here. Yes, this is the formula. Okay. And then you will get g is negative 24y negative 36. Okay, you have 2 points. Okay, we try this first. 0, 0 and 9, negative 3. 0, 0 first. So if I put 0, you will get negative 36. If g less than 0, which means saddle point. So your 0, 0 will be saddle point. Okay, how I get 0, 0 and 0? Don't forget, if you get the point 0, 0, right? Every time when I get this point, I will substitute here. Okay? Every time I get this point, I substitute here. So if I have f0, 0, by means this is 2, 0, cube minus 6, 0 times 0 minus 0. So you get 0. 9, negative 3 means f9 negative 3. So 2 negative 3 cubed minus 6 times 9 negative 3 minus 9 squared. Okay, how much? Try to calculate. f93. I just put in fxy. Calculate for me.
I got minus 81, doctor.
Minus
81?
51.
81.
Again?
I got minus 81.
81. Okay. Well, what is your name?
Sophie?
Sophie. Okay, thank you, Sophie. Others? If I put 9 negative 3 here, what would it be? fxy. 27. Okay. Others? Which is correct? See, so a lot are saying 27. Okay. So we check. Okay, I check. We check first. So this is 2 times with 27. With 27 minus plus, is it? This is 54 times 3. 3 minus 81. So this is 54. Okay. So what will be 54 times 3 will be 21162 minus 81. Right? See, is there any wrong? Cube minus 6 times 9, 54 times 3. 1, 16. So what will be? Okay, let me check. $54, 162 minus 81. So what will be? Be correct. See anything wrong? Okay. Okay. See, we have answer or not here. It's 27. Okay. Should be 27. So where is the wrong? Where is the wrong part? Oh yeah, this is negative. Okay, this is negative. Okay. So you get 27. Okay, good. Okay, so you have 2 points. 1, 0, 0, 0. Actually, this is 0, 0, 0. You can write this as 0, 0, 0. So this is 9, negative 3, 27. So for G9, negative 3, you substitute here. 9, negative 3. But there is no value for X. So 9, negative 3, you put negative 3 here. And then you get 36. So which means G more than 0 and your fxx is less than 0, which means G more than 0, your fxx more than 0, less than 0, sorry, more than 0, and your fxx less than 0, which means your function will be, your point will be local maximum. Okay, fxx less than 0 and G more than 0. Okay, so you will get local max. 9, 83, 37 will be local max. 0, 0, 0 will be saddle point. Okay, do you have a question for this? Any question? You see other example. Okay. F, something like this. They give this. Okay, as usual, find fx and fy. Okay, I think let me do it so that you can see how is it. Okay. So first you have to find fx, right? Fx you have to equate with 0. So fx will be okay. We do number 2. It will be negative 2 x equals to 0. So x will be 0. Fy is 3y squared over 3 minus 0 minus 1. This is y squared minus 1. This is y minus 1, y plus 1. Okay, then y equals to 1, negative 1. So you have negative 1, 0, sorry, 0, negative 1. You have 2 points now. 0, negative 1, 0, 1. You have 2 critical points. See, they correct or not? Yeah, 0, negative 1, 0, 1. Okay, next you find the G, right? G. So G, what is the formula? F x x times f y y minus f x y squared. You check the formula. So make sure you remember the formula. F x x, f y y, f x y. Okay? Try to find first. Okay? So f x x will be negative 2, right? From here, fx is negative 2x. Then fy is y squared minus 1. Okay, so fyy will be 2y, right? Okay, you have this, and then you have to find fxy. So fxy will be 0. Okay. Okay. So your formula will be fxx is negative 2 times 2y minus 0. This is negative 4y. This is your gxy. Okay. Okay. So your point, so your fxx is fixed at negative 2. Okay. And then when try to see 0, negative 1. So 0, negative 1 will 4. And when 0, 1 will be negative 4. So this is more than 0. This is less than 0. This is always less than 0. Okay. So in conclusion, we can say that G 0, 1, negative 4. Correct or not? Yes. G 0, 1, G 0, 1, negative 4, which is less than 0. Your fxx is negative 2. Therefore, you can say that if G less than 0, straight away you can say it is a saddle point. For G less than 0, you can say that the point is saddle point. Okay, but before that, don't forget to substitute here 0, 1. If the point is 0, 1, your f 0, 1 will be x is 0, right? 1 over 3 minus 0 minus 1. So 1 over 3 minus 1 will be negative 2 over 3. If your point is 0, negative 1 means f 0, negative 1 is equals to negative 1 over 3 minus 0 minus 1, which is negative 1 over 3 plus 1. This is 2 over 3. Okay. So here, so you have for 0, 1, negative 2 over 3 will be saddle point. 0, 1, negative 2 over 3 will be saddle point. And for G0, negative 1, you get more than 0, right? You have 4, which is more than 0, which means you have local maximum because your fsx is negative 2. Okay? So one is saddle point, one is local max. Is it okay? Understand? So hi Arifin, you ask me, okay, your question is why did fxy 0? Okay, why? Okay, let me show you. Okay, here or here, fx is, so this is 0, negative 2x, right? And the fxx will be negative 2. Okay, fy will be y squared minus 1. fyy will be 2y. fxy, if I differentiate this respect to y, will be 0. Even I differentiate this fyx respect to fy, and then I differentiate respect to x, will be 0. The same. Understand, Zuhair Arifin? Okay, are you there? Okay, Zuhair. So do you have any question? Understand? Any question for the local extrema? I think absolute is out of syllabus. Let me check the course outline. So I see here, okay, we have done domain range, partial higher order we have done yesterday, chain rule and implicit also yesterday, rate of change we have done one question, increment and total differential done, extrema relative. Okay, we don't have absolute here, so we will skip the absolute, but I think error is, let me check, error should be here. I think they missed the error. Okay, let me check the old CI. Last time we have the absolute, but now we have excluded. So I think we will move to error, but before that we rest for a while, okay, and then we continue to error. So I will give extra note. So we don't need go to absolute, but let me tell you some ideas. Okay, for absolute minimum or maximum, there must be only one. Okay, between the two critical points, we have only one absolute minimum or absolute maximum. Okay, but because we will not touch on this, so Okay, but you can do as an exercise, but no need to find the absolute minimum. Just find the saddle point or local max or local min. Okay, so we wait for a while, take rest. We will continue 5 minutes later. Error. Okay, basically about the error, they are similar to the total differential and approximate change. Okay, so the formula you might use will be like this: equals to x delta x plus fy delta y. Okay, usually we will use this. So this is error, estimation of error. Okay, then maximum error, you will put modulus. Okay, you will put the modulus sign. F x delta x, or we can put like this, okay, plus fy delta y. Also, you can, for 3D, it will be more than one independent, more than two independent variable. Okay. Okay. So another one, you might see maximum percentage error. Percentage error. Okay. The percentage error will be del z over z. Okay. This is the formula. Fx delta x over f, okay, xy. So your f is equal to z, same. Okay. Here, let's say I put z equals to fxy. Also z here. Same thing. Plus fy delta y over. So this will be a maximum percentage error. So remember, this is maximum error. This is maximum percentage error. Okay. And then for 3D, just the same. Okay, we check. So for 3D, we use del W. Okay. Del W equals to fx del x, fy del y. The same formula as the increment. Then, okay. Okay. So this is increment, and then maximum error. Right? Maximum error will be, just put the modular sign, fx. So the w function of x, y, z. Okay. Fx del x plus fy del y plus fz del z. So remember the word maximum, you have to put the modular sign. Okay. So maximum percentage error will be del W over W. So Fx del X over, you can put W, so no problem, or you can put Fxyz, no problem. But I think better put Fxyz so that you're not confused. Plus Fy. Then lastly, plus Fz delta Z over okay. Okay. Same as W, okay? We can put W. So I think that is for error. So now we will do some examples so that you can understand. Okay? Okay. So you might copy, or later I will give this. Okay. Example 1. Given Z equals to X over Y. Find the maximum error. Find the maximum error in Z using the derivative if the maximum error of in X is 0.1, okay, 0.4 cm, and the maximum error in Y is 0.2. Okay. So one is 0.4, 0.4, another one is 0.2. When X is 8 cm and Y is 4 cm. This is the question. So solution, so we have X equals to 8, we have Y equals to 4, we have delta Y 0.2 and delta X is 0.4. Okay, these are given. So this is translate to delta X and this will be delta Y. So we know in this formula we have Fx and Fy, right? So we need to differentiate this function, the Z function. So you can let this as Fxy. So Fx will be 1 over but Fy, okay, you have Fx, Y is X over Y. You can write this as X, Y, -1. So Fy will be negative X over Y squared. Okay? Which means you bring -1 to left, downwards, to -1, you push it inside. Okay, you got everything now. So you can put in the formula del Z Fx del X, so this is the formula, plus Fy del Y. So what do you have here? 1 over Y. 1 over Y squared. 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 delta x will be 0.4. Fy is negative x over y squared. Del y will be 0.2. Okay, but also they give when x equals to 8, y equals to 4. You can substitute y equals to 4 plus, so x is what? 8, right? Negative 8 over y is 4 squared times with 0.2. So we have modular sign, so everything that is negative will become positive. So this will be, okay, y is 8, right? Y is 4. Y is 8 or 4? Y is 4. Okay, so this is 0.1, correct? Plus, okay, please calculate this to me. What will be here? 8 divided by 16 times 0.2. So what will be here? 0.1.
0.1, doctor.
0.1.
Yes.
Okay, so 0.2, correct? Check. So everyone check.
Correct, doctor.
Okay. So these are one example. Okay. So in the same question, if they ask you to find maximum percentage error, will be delta z over z. Will be fx delta x over f or z. Okay, I can put z here. Same. Plus fy delta y over z. Okay, so now fx is 1 over x, right? What is fx? 1 over y. 1 over y. Okay, check. Yes, fx is 1 over y. Then over x over y. Delta x. Sorry, this is delta x. Okay. Plus fy will be negative x over y squared delta y over x over y. Okay, so what will I have here? So y can be cancelled. This is delta x over x. Plus this is delta y over y. Okay, but what is delta x over x? So they should give, okay? So they didn't give here. So let's say they give you maximum percentage error for x will be 4% and the maximum percentage error for y will be 2%. Say, let's say. Okay, I miss out this. So you have 4% plus 2%, which is 6%. 10. So this is the symbol for maximum. Okay. Maximum percentage error. Okay. So others are the same. So let me give some example on 3D. If we have X, Y, and Z. Okay. Let me see. Okay. So say that if we have W equals to X squared square root Z over cube root Y. Okay, so you can write this as X squared Y to the power of negative 1 over 3 to power of half. And find the maximum error in W using the partial derivative if the maximum error of X, which means del X, maximum error of X, del X. Okay, remember maximum error, which means this percentage will be del X over X. Remember this. Okay. So maximum error of X will be 0.4, of Y will be 0.3, maximum of Z will be 0.1. When equals to Y equals to 8, Z equals to 4. This is the question. So you know the formula will be to find the maximum error. Find maximum error in W. So this is the question. Find the maximum error in W. So delta W will be Fx delta X, Fy delta Y, Fz delta Z. Okay, so I think it's boring if I'm only do this. So I think I will choose among you. Okay, be ready. I will choose among you that can solve this question. Okay, where are others? Are you there? Hello?
Yes, doctor.
Okay, who is that?
It's me, Abdikafi.
Abdikafi. Okay. Can you find for me Fx for this?
Yes, sure.
Okay. Find Fx, okay? Abdikafi.
Yes.
Okay, others volunteer? Who is that? Adriana, Ardini. Ardiana? Tami? Tai Yo Wen? Tai Yo Wen. Hello? X. So which means y and z will be constant. Very easy. 2x, 3, z half. Okay, fy will be x squared remain, negative 1 over 3 here. Y negative 1 over 3 minus 1, which means minus 3 over 3. Z half. This will be minus x squared over 3, negative 4 over 3, z half. So fz will be x squared same, negative 1 over 3 same, half z negative half. Okay? 1 minus half, half minus 1. We check. Okay, Abdi Omar, good. And then this is Sinchi. Sinchi. Okay, good. Okay. Then lastly will be husband. Square. Okay. So good. Everybody know to differentiate. Make sure you know that. And then you just substitute. Okay. You substitute the value. Here fx will be 2x is square root z over cube root y. I just put like this. And then plus negative x squared square root z over 3 cube root y to the power of 4. Okay. This is del y. And then plus x squared over 2 cube root y square root z. Okay. And then you substitute. When x equals to 2, y 8, z equals to 4. Okay. 2 times 2 is square root 4. X is 2, y is 8. X is 2, y is 8, z equals to 4. Okay. Cube root 8 times with 0.4. Check again. Is delta x 0.4? Yes, 0.4, 0.1, 0.3. Okay. Plus negative 2 squared square root 4 over 3 cube root 8 to power of 4 times with 0.3 plus 2 squared over 2 times cube root 8 square root 4 0.1. Okay, so you will get the answer. Okay. Okay. Then if they ask you to find the maximum percentage error, so your formula will be del W over W fx over W times this is fx delta x. Okay? F y delta y over W. F z delta z over W. Okay? But they have to give you the percentage error of delta x over x. They have to give you maximum percentage error in x. So maximum percentage error in x is 1%. Maximum percentage error in y is 3%. And maximum percentage error in z will be 2%. So you have to make somehow to look like this. Okay? So the answer is 4%. So try do it by yourself. Okay, then come check with me. Okay? Yeah, I might be wrong, but if you check, if you do by yourself, then you can understand what is going on. Okay. So I think we have done with chapter 2. Okay. We're done with chapter 2. In the next class, we will move to chapter 1, part 2. Okay. You see here. Check. Okay. So we will move to graph of function of several variable. Okay. So this will be a little bit hard, but it's okay. We can manage it. Okay. Okay. Any question? So see you in next week. Okay. So we have done chapter 2 and we move to chapter 1 part 2 later.